We'll go over this interactive physiological signal visualization. This is in production, and we have a 12 minutes overview by Notebook LM, so just gave it the code, this text description below the page.
It simulates physiological responses, so it doesn't just show you, it kind of lets you feel that connection between your mind and body.
Exactly.
You shared some great material on this, and our mission really is to unpack how our thoughts, our emotions, how they literally change our physical signals right there in real time. It's pretty eye-opening stuff.
It really is. And what's so revolutionary, I think, about this simulation is how it just demystifies these really complex psychophysiological concepts, makes them tangible.
Right, less abstract.
Yeah, it's built on, solid science, rigorous studies, lots of data, like from the PhysioNet research. They tracked very carefully how things like cognitive load, from mental tasks and emotional arousal, maybe from music, how they influence our physiological signals.
So it takes all that complex data
and turns it into something you can see and interact with. It's science made accessible, really.
Yeah.
A living visualization.
That's the magic, isn't it? Bridging that gap. So, okay, for our listener who's thinking, I want to try this, what exactly is this interactive simulation? How can they actually use it to see their own mind-body connection working?
Right. Well, at its core, it's like a dynamic window, a real-time window into how we respond physiologically.
Okay.
Imagine seeing your heart rate change, your breathing, even your sweat response shift, not just in theory, but like right there on the screen.
Because of what you're thinking or feeling.
Exactly. Because of the different mental states or emotional inputs you introduce.
Yeah.
The main goal is just to make these ideas, biofeedback, human-computer interaction, easier for anyone to get a handle on.
Students, educator.
Yeah, students, educators, or honestly, just anyone who's curious about how their own body works.
That sounds incredibly useful. So how do you actually, use it? How do you interact to see these connections yourself? Is it just watching or is there more to it?
Oh, it's definitely designed for active engagement.
Yeah.
You can use something called manual mode.
Okay.
There's a drop-down menu, and you pick a condition, like maybe calm music 1 back. That's low mental effort.
Right.
Or you could choose exciting music 3 back for, a bigger challenge.
More stimulating.
Yeah. Then you just hit start visualization.
Right.
And what's really cool is you can even switch conditions while it's running.
Oh, interesting. So you can see the shift.
Exactly. You see those gradual, sometimes really subtle physiological changes as you mentally kind of shift gears.
And what if someone just wants a quick overview, like a taste of what it can do?
Yep. There's a demo mode for that. You just press auto demo 20. And the simulation automatically cycles through different conditions. It's a really quick way to see the range of the body's responses without having to do anything manually.
Okay, that makes sense. But beyond just setting conditions, are there deeper ways to interact? Something that really lets you feel like you're part of the experiment, not just observing?
Absolutely. That's key. You can, for instance, click or tap right on the visualization screen.
Okay.
And it marks that specific moment with a visual marker. So maybe you had a thought or heard a noise. You mark it, and then you can watch for the physiological shift that follows.
Ah, to correlate events.
Precisely. And crucially, there's the end-back task itself. The letter memory game.
Right.
You actually respond using the Y and N keys on your keyboard.
Okay. Yes or no?
Yes or no. And your score updates right there instantly. So you can directly link how well you're doing the task to what your body's doing.
Wow.
And for really getting immersed, there's an audio ECG switch.
What does that do?
It plays realistic heartbeat sounds, perfectly timed with the ECG signal you're seeing.
Oh, that's cool. It really makes the data feel more alive.
It does. It adds another sensory layer to the whole experience.
Yeah, I can imagine that audio feature adds a whole new dimension. So, okay, let's peel back the layers then. What are the actual signals we're looking at? When you see those lines moving on the screen, what story are they telling us?
Great question. So the simulation focuses on 4 key things, 4 signals.
Okay.
First, there's the end-back stimulus. Now, this isn't technically a physiological signal from you. It's the task given to you.
The input. Right.
Exactly. Letters pop up, every 2 seconds? And your job is to say if the current letter matches the one from N steps ago.
Like 1 letter back or 3 letters back?
Right. 1 back or 3 back, depending on the condition.
Yeah.
It's a classic way to just add some cognitive load, make your brain work a bit.
Okay, so that's the trigger. What about the responses? What are we seeing from the body?
Right. So next you've got the ECG. That's shown in green. Your electrocardiogram,
Heart activity.
Yep, the heart's electrical activity. You'll see those familiar shapes, the QRS complex, T waves. And what's really clear is when you ramp up the cognitive load, like with the 3-back task, or if the music gets exciting, you'll literally see your heart rate, the BPM, go up. Those green peaks get closer together. It's a direct visual of your heart responding.
Fascinating. Okay, what else?
Then there's EE, shown in blue. That stands for electrodermal activity.
ED, what's that measuring?
It's basically measuring how much your skin conducts electricity, which sounds weird, but it's a direct reflection of sweat gland activity.
Oh, okay, sweat.
Yeah. And sweat glands are really tightly linked to arousal or stress or even just being highly focused. So more stress usually means a higher EDA level overall, and you'll see these kind of slow-moving peaks. Yeah, and this is important. These peaks have a realistic delay, about 1 to 3 seconds after something happens.
So it's not instant like the heart rate change might seem.
Exactly. It reflects how that part of your nervous system, the sympathetic system, takes a moment to kick in. It's not an immediate switch.
Wow, the level of detail is amazing. That delay is modeled in. Okay, what's the last signal?
The last one is RESP in red. That's respiration, your breathing.
Makes sense.
You'll see the pattern, the natural changes in depth and rhythm. And similar to heart rate, you'll generally notice your breathing rate, the RPM, tends to speed up during the more demanding conditions.
Harder task, faster breathing.
Usually, yeah. Or more exciting music. Faster breathing.
Yeah.
Another really clear, visible sign that your body is, gearing up or reacting.
This is incredibly sophisticated. It's connecting dots that, honestly, I don't think most of us even realize are connected day to day. So when you put all these signals together, the heart, the sweat, the breath, reacting to the task, what's the most maybe surprising or counterintuitive aha moment this simulation gives us? Like, what really stands out?
One of the really striking things, I think, is how our bodies react to different kinds of stress. So, for example, try comparing two conditions. Say, calm music 3-back. That's high mental effort, right? But low emotional impulse.
Right. Difficult task, calm setting.
Yeah. Compare that to, say, exciting music 1-back. That's low mental effort, easy task, but high emotional arousal from the music.
Okay, so different sources of demand.
Exactly. But when you look at the physiological signals, the ECG, EDA, RESP, they can actually look surprisingly similar.
Really? Mental strain and emotional excitement can produce the same stress signature?
In many ways, yes. The body's core stress response can look very similar. It really makes you question, does my body always know the difference between good stress and bad stress, or mental versus emotional?
That is fascinating. It's like the body just registers demand or alert. What other kinds of subtle connections does it bring to light?
Another really cool one is something called Respiratory Sinus Arrhythmia, RSA.
Okay, RSA, what's that?
Look really closely at the ECG trace, the green line. You'll notice the space between heartbeats isn't perfectly even. It actually changes slightly with your breathing.
Oh, yeah. How?
Your heart rate naturally speeds up a tiny bit when you inhale and slows down a tiny bit when you exhale. It's linked directly to the RESP signal, the red line.
Wow. So the heart isn't just beating like a metronome. It's kind of breathing along with the lungs.
In a way, yes. It's a direct visual of that connection. And it immediately makes you think, okay, how connected are breath and heart? And could I maybe influence my heart rate or my stress level just by changing my breathing, which of course is the basis of many relaxation techniques.
Absolutely. That's a powerful visual link. It makes you appreciate how interconnected everything is.
It really does. And speaking of connections and timing, think about the EDA latency in kinetics.
The delay in the sweat response you mentioned.
Exactly. When something happens, a new letter appears, you make a response. That blue EDA line doesn't jump instantly. There's that characteristic delay, maybe a second or two, then a slow climb and a slow fall.
Right.
And that's not a bug. It accurately shows the slower acting nature of the sympathetic nervous system, your fight or flight system. It doesn't just flick on and off. It ramps up and ramps down.
It's a gradual response, not a sudden jolt.
Precisely. Then there's also habituation or adaptation.
Okay, what's that?
If you just let one condition run for a while, maybe like 4 minutes or so, you'll often see the intensity of the responses. The heart rate increase, the EDA peaks, they start to lessen. They get smaller.
So your body gets used to it.
Exactly.
Yeah.
It adapts. Your physical reaction to that same continuous stressor starts to decrease over time. It's like background noise. At first it's jarring, but eventually you kind of tune it out. Your body stops reacting so strong.
That makes perfect sense. Conserving resources, maybe?
Could be. It shows our bodies are constantly adjusting.
Yeah.
And finally, something I think everyone can relate to.
Uh-oh. What is it?
Error-related stress.
Making mistakes.
Yes. When you mess up on the N-back task, you press N when it should be Y, or vice versa. The simulation shows you an N error, little red cross.
Right, feedback.
Pay close attention to that blue EDA line right after you see that error. Very often, you'll see a little spike.
Just from making a mistake.
Just from making a mistake. It clearly shows how performance errors, just realizing you messed up, can act as these immediate little internal stressors. Your body literally reacts to your own cognitive slip-up.
Wow. That is incredibly insightful, seeing that visualized. It really drives home how much our internal state affects our physiology. It's just incredible, isn't it? How a tool like this can make that intricate dance between mind and body so visible. This whole deep dive, it's really shown us how things like cognitive demands, emotional states, they aren't just abstract concepts. They translate directly into physical signals we can actually measure and see. Heart rate, sweat, breathing.
Yeah, it moves it from theory into reality right there on the screen.
It's not just theory anymore, it's a living demonstration.
And if you connect that to the bigger picture, it profoundly underscores how deeply intertwined our mental and physical states really are. They're not separate things.
Not at all.
Understanding these signals, seeing them in action like this, it can offer really valuable insights, for managing stress better, maybe improving focus, even enhancing performance in whatever you do.
Absolutely.
And it leaves us with, I think, an important question, something for you, the listener, to think about.
Okay.
What other subtle physiological signals might your body be sending you all the time? Or maybe even broadcasting to others that you're completely unaware of right now?
Like subconscious cues.
Exactly. And how might becoming more attuned to those silent messages, those internal signals, how might that change how you perceive yourself or how you navigate your daily life and interactions?
Yeah, there's a human in the loop, just in case you have any questions. All the tools we're making are available on BioniChaos.com.